All right. Today we are going to address the two-sample confidence interval for means, and I'm going to refer to the problem we worked on last time when we did a test for means. I'm going to just enlarge this very quickly. So if you remember, Hayden took a sample of 10 one-bedroom apartments, which is here, and he took a 10 sample of a two-bedroom apartments. He did not collect the data properly, as you can tell in here. And in the last video, we addressed this problem. We performed a significance test. Today, we are going to look at a 95% confidence interval. And of course, it goes without saying, we need to interpret the interval in the context of the problem, okay? So, the conditions are literally the same. Nothing changed. In the past, we had to state H null and HA in symbols and words, and then name the appropriate test. For now, we're doing a confidence interval. So all we have to do is name the appropriate test. So this is clearly a two-sample t-test, not a z-test. And it is a confidence interval for means, not for proportions. Okay. The conditions are the same, but I wanna point out something a little more forcefully so it is clear. The first one is on the SRS. We were not told that it is an SRS, so we shall proceed with caution. And then we know from the central limit theorem, X bar will follow a normal distribution if the parent's distribution is normal. We don't know anything about the parent distribution, which is all the two-bedroom and all the one-bedroom apartments in the college campus, at the college campus at Stanford. So we have to require that the sample size have to be at least 30, and we don't. N1 and N2 are both less than 30. So that was one problem. The second problem, if you remember, the t distribution is extremely sensitive to outliers. And so we have two problems with this condition. The least you can do is to sketch a graph, maybe a box plot, of the first sample and of the second sample separately, and see if there are any outliers. If there are, this problem is over. We can't do it. If there aren't any outliers, we just have to proceed with caution. And that is the reason why I said extreme caution is needed, okay? The 10% condition is fulfilled because we assume there are at least 100 one-bedroom apartments in that area, and there is at least 100 two-bedroom apartments in that area of Stanford. So the 10% condition is fulfilled, and the reason we use this condition is so we can use the standard deviation of X bar to be sigma over root n in general, okay? So step 2, we're gonna do the calculation, which is always the easiest thing for students to do. Just remember the skeleton, okay, or the blueprints. The parameter is captured by this interval. What is the interval? It is my statistic minus the margin of error, and then statistic plus the margin of error. Notice that the statistic is always in the center. I'm going to write this down. So if you have an interval called A minus B, A plus B, okay, what it means, these are conjugates, right? It means A is in the center of your interval. So if you add B, you get to this endpoint here. And if you subtract B from A, you get to this endpoint of this interval. So when you see statistic minus margin of error, statistics plus margin of error, it means the statistic is in the dead center of your interval, okay? And then you add a margin of error and you take away a margin of error. What is that margin of error? It is always T or Z times the standard error of my statistic. I don't want to write standard deviation. It's a little confusing. So I'm just using the word standard error of my statistic. My statistic today is x2 bar minus x1 bar, okay? Let me erase what I just wrote here. So my statistic is the same statistic as we did previously. It is x2 bar minus x1 bar. I could have used x1 bar minus x2 bar, but I'll have a negative number. So I chose to look at the cost of the 2-bedroom minus the cost of the 1-bedroom apartments, okay? So this is my statistic. And so that's the general formula, okay? Now, so the parameter, which is mu2 minus m1, is captured by my statistic minus t, not z. This is called critical value, this t. That's why we put as t star so we don't confuse it with the old t. It's a critical value times the standard error of my statistic, and then the same thing here, okay? Now, the standard error of a difference is the standard error of one of them squared over its sample size plus the standard error of the other piece squared times squared divided by its sample size. I forgot to put bars here. Okay. Now, last time I made a mistake and I wrote something like this, and I hope you caught it. I wrote x2 bar over n2 squared. And the same thing for S1, that's incorrect. You just divide n by n1 and n2 without squaring. It's just a careless error, okay? So that's the general formula. I'm going to show you how to find the confidence interval using two methods, as you know. The first method, which is always the favorable one and the easiest one to handle, is to use the graphing calculator. You go to stats, tests, you go to 0. 0 is right after 9. I think it's a 10, but they're not writing 2 digits, so you just see 0. It's literally the button after 9. You look for a 2 sample t interval. Clearly, we have data. We don't have statistics. Data means lists, so they are put under L2 and L1. And you choose the exact confidence level that they are asking you. So they said 95% confidence interval. That's what they're looking for. You literally copy that thing. You don't add 2.5%, okay? And there is another error from last video. I said we're not pulling. In fact, we haven't done any problem where you have to pull the data. And I circled yes, even though I was saying no. So go to the previous one. Just make sure it's a no. To pull, by the way, to pull the data, which happens every now and then, we would use... let's say we're dealing with proportions, the pooled proportion. You add x1 to x2 and you add by the total. We have never done a problem like this, okay? So generally speaking, we don't pool, and that's what I said last time, but for whatever reason, I end up circling yes instead of circling no, okay? So make sure you circle no in the previous problem. It's actually the question A of the same problem we're working on today. It's this question, okay? All right, so we don't pull, and then you get the interval right away. So the conclusion, which is your last step, should say step 4. Okay, the last step is to draw the conclusion in the context of the problem. And the way you say it is this way. We are 95% confidence that the true difference, that means mu1 minus mu2, in rent between the 2 and the 1-bedroom apartments is captured by this interval, okay? This is step 3. I want to make sure we get it right. Okay, let's go back here. Yeah, step 1 and 2, 3, and 4. And I can also do this in black. Okay, the other approach, and it is really a good exercise to go through it to see if you are right and to understand what's going on. You go to stats, calc, 2 var stats, because we're dealing with 2 columns. You pick you pick X bars, the two X bars and the two standard deviations, and N1 and N2. You need 6 numbers, okay? Why? Because this formula here requires 6 numbers, 1, 2, 3, and in this one you have 5 and 6, maybe more, actually 7. So you have the standard deviation, another standard deviation, the two sizes, N1 and N2, that's 4, 5, 6, 7, okay? So, under 2 var stats, you get 1, 2, 3, 4, 5, 6, they're the same, and 7. Now, this one is not given on the TI, okay? The way you find it, I put a picture here for you. This is what I did the other day, but I didn't have column below 17. So we're gonna pick the minimum of N1 and N2, and I would subtract 1 because degrees of freedom is N minus 1. So I would pick 9, okay? If you pick 9, let me draw it for you. If you pick 9, so the minimum, I made a mistake also last time. So the minimum of N1 minus 1, N2 minus 1, okay? I wrote N1 and N2. I forgot to subtract 1. So 9, and then you pick your confidence level, and that gives me my critical value T, okay? So T star is 2.262. Okay, that's how I got that 7th number, okay? Let me erase this. Okay, so we're gonna go back. Gonna go back here. So this gives you 6 numbers, 1, 2, 3, 4, 5, 6, and then the 7th one you could pull it from the TI, and you put them in here. And you should get the same interval, and then of course you draw a conclusion in the context of the problem. So that should end this video.